Hi everybody, welcome to AGAA-MATH. This is Rakesh. Today, here I am going to introduce about real numbers. So, to know about the real numbers, we have to recollect the few things which we have learned in our previous class. Okay, let us see what numbers are called real numbers. Right. If you see in this row we have only one apple is seen here. In this row how many apples are seen? 1, 2, 1, 2. And in this row how many apples are seen? 1, 2, 3. Right? So 1, 1 and 2, 1, 2 and 3. Right? So here we are counting. How many apples mean? This is just one apple. How many apples are here? 1, 2. And here 1, 2, 3. Right? So here to find out how many are these in each row means we are just counting the numbers. Right? Now if you observe here we can see only one coin. Right? We can see only the one coin here. Here we have just two coins. And here 1, 2, 3. And here 1, 2, 3, 4. And here 1, 2, 3, 4, 5. Means whenever we would like to count, we are beginning with 1. Right? So it's very clear now. Right? So to count whatever the objects or the things or whatever it may be, whenever we would like to count, we begin from 1. Right? So such a numbers is nothing but natural numbers. Natural numbers. So these natural numbers are represented with the capital letter N, so that N equals to what? 1, 2, 3, 4, so on. So that any set of natural numbers, N indicates a set of natural numbers where begin from 1, 2, 3, so on. So that what is the least natural number? 1. 1 is said to be the least natural number. Least natural number. Right? So what is the greatest natural number means? It is undefined because it goes on. We can count infinity of numbers. We can write infinity of numbers. So we cannot say what is exactly largest natural number, it is called undefined. So the least natural number means 1. 1 is the least natural number. Now let us see the next. So natural numbers, right? Natural numbers is nothing that begins from 1 because they are counting numbers. So whenever we would like to count, we just count begin from 1. So 1, 2, 3, 4, so on. So these are said to be the natural numbers. Okay, so in the set of natural numbers, if we include 0, then that number is nothing that set of natural numbers is nothing but whole numbers. So the set of whole numbers is denoted by W. So these are said to be the whole numbers, right? These are said to be the whole numbers. So set of whole numbers are denoted by capital letter W. Next, this all we have learnt in the previous classes. So just to recollect. And next we have integers, right? We use integers. Okay. So integers is nothing but whole numbers, set of whole numbers. So these are said to be the positive numbers, and if you come towards the left side, we can see the negative numbers. So on. So the positive numbers and negative numbers, these are said to be positive numbers, and these are said to be what? Negative numbers. So positive numbers negative numbers. Including 0 is said to be the integers. Integers are denoted by Z. Integers are denoted by Z. So natural numbers, whole numbers, integers. Right? So all natural numbers are whole numbers or not? See here. All natural numbers are whole numbers because natural numbers 1, 2, 3, 4 which are in the set of whole numbers. So all natural numbers are whole numbers. Is all whole numbers are integers? Yes, whole numbers means 0, 1, 2, 3, 4, so on, right? So 0, 1, 2, 3, 4, so on we have in this. So all whole numbers are integers, right? So this easily can understand that natural numbers, whole numbers, and next is integers. Right? So another numbers we have that they are rational numbers. So what are called rational numbers? Let us see, which we have learned in our previous class also. Before you watch the video, subscribe it, click on the bell icon for more notifications. Rational numbers. Right? Rational numbers. Here, rational numbers means what? The numbers which can be written in the form of P by Q, where Q is not equal to 0. And next condition is P comma Q means P and Q are integers. P and Q are integers. P and Q are integers. So numbers which can be written in the form of P by Q. P by Q means, see, 1 by 2 is a rational number. 3 by 5 is a rational number. Minus 3 by 7 is a rational number or not? Let us check the condition here. See that P by Q form. Yes, minus 3 by 7 is in the form of P by Q. Q is not equal to 0. Yes, where here Q is in the denominator, so that denominator is not equal to 0. P, Q are integers. Is minus 3 is an integer? Yes. 7 is an integer? Yes. So that minus 3 by 7 is a rational number. Let us say another. Or 7 by minus 7 minus 8. Is this a rational number or not? Simple, check. Q not equal to 0 means denominator is not equal to 0. P and Q are integers. 7 is integer, minus 8 is integer. So it means this is also a rational number. Is 1.7 is a rational number? 1.7 is a decimal number, right? Is also called a rational number or not? Let us write in the form of, represent this decimal number in the fractional form or in the P by Q form. Represent this 1.7 is the P by Q form. If you do that, it is 17 by 10. 17 by 10. Q is not equal to 0. 17 is an integer, 10 is an integer. Means it is a rational number. It means 1.7 is also a rational number. Means what? Even decimal numbers are also rational numbers. Let us take one more example here, 23.168. Can you write in the form of P by Q? 23,168 by 1000. Right? So this is in the form of P by Q. This is also integer and this is also integer. So that this is a rational number. Means very simple, numbers which can be written in the form of P by Q. Q is not equal to 0 and PQ are integers. Such all numbers are said to be a rational numbers. Now in these rational numbers we have two types of numbers. Okay, they are terminating and non-terminating. They are terminating and non-terminating. So what is terminating and what is non-terminating? Let us see now. For example, if I take a number here if I take a number like 7 by 5, means if you would like to convert into decimals, that is 7 by 5. 7 is divided by 5. 5 ones 5, 2 remains, so I use a point here, so it is 0. 5 fours 20, so remainder 0. It means 7 by 5 is equals to what? 1.4. Let us take another like 23 by 8. Convert this into decimal form. 23 divided by 8. 8 to 16, 8 3 is 24. So 8 to 16. 7 remains. So 0.0. Now 8 8s 64. 6 as you have 0.0. 8 7s 56. So 4 as it is 0.0. 8 5s 40. Here the remainder is 0. Means 23 by 8 is can be written as 2.875. So if you observe here, the decimal part ends at some point, some number, it does, right? So these type of a rational numbers are said to be terminating decimals. Terminating decimals. When you do division, it ends at some point. It ends with some decimal number. So that's what these are said to be the terminating decimals. Okay. So let us see the non-terminating. What rational numbers are called non-terminating? Now we will see. That is, if I take an example like 2 by 3 or 16 by 3. Let me take 16 by 3. It means 16 divided by 3. 3 5s 15. 1 remains. Point if I consider this is 0. 3 3s 9. 1 0 again. 3 3s 9. 1 as point was there, it is 0. 3 3s 9. 1 again you get 0. Means by observing this we understood that 16 by 3 is nothing but 5.3333, so on you go gets. If you continue this division, you will get so on 33333, so on. If you observe this, you can understand. So here the decimal number doesn't end with any number. It doesn't end. The decimal number is continuing. Right? Such numbers are said to be non-terminating. 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 Such are said to be non-terminating. Okay. Let me take one more example. Here I take 2 by 11. 2 by 11. 2 by 11. If you would like to convert into decimal, 2 divided by 11. So 11 0 0. So if I use point here, it is 0. Now 11 ones 11. 9. So as you have point here 0. 11 8s 88. 2 remain 0. 11 ones 11. 9 remains again 0. 11 8s 88. Again 2 0. 11 ones 11. 9. So again we take 0. 11 8s 88. Again 2. Means if you observe here, 18 18 is repeating. So 2 by 11 can be written as 0.181818, so on. So it doesn't end with any decimal number, right? So these type of a numbers, these type of a rational numbers are said to be what? Non-terminating. Non-terminating. So I hope you understood. Terminating means when you do the division, it ends with some decimal number. When if it continues on, so that is a non-terminating. If not, if it ends with some decimal number, that is a terminating, right? So I hope you understood what is a terminating and what is non-terminating, right? So this is about a rational number types like terminating and non-terminating. And now we will see what are the again about non-terminating. In non-terminating we can see two types of things. Let us see now. Before we have already done that 16 by 3, so that we got that is 5 point, right? 5.333, so on. So we knew that this is a non-terminating, where it can be written as 5.3 bar. So this is a non-terminating. And in the before we have taken 2 by 11. When we converted into decimal, we got 0.181818, so on. And we knew that this is also a non-terminating with 0.18 bar, right? So these are non-terminating. And in this non-terminating, you can observe that 3 is repeated, and here 18 is repeated. Means in non-terminating, these type of a rational numbers are called non-terminating repeating. Non-terminating repeating. Non-terminating repeating. Okay. In the next coming up classes, we can see few type of numbers like 6.132178937417283337, so on. Means this is also non-terminating, but here if you observe here, there is a repetition, but in this no repetition of numbers like that. Means with certain order, right? So this type of numbers are also non-terminating and non-repeating. Non-terminating, non-repeating. Okay. Non-terminating, non-repeating. Even we can take any like 0.141236187198231667, so on. So this is also non-terminating and non-repeating. So these type of numbers, if you see, this type of numbers are called irrational numbers. Irrational numbers, right? So rational numbers already we have learned, and then these non-terminating, non-repeating are said to be irrational numbers, right? And rational numbers are denoted by what? Rational numbers are denoted by Q, and irrational numbers are denoted by Q dash we call, or Q inverse we say. Okay, so these are irrational numbers. So what real number means? Natural numbers. Okay, natural numbers, whole numbers, integers, rational numbers, irrational numbers. Set of rational and irrational are said to be real numbers. Rational means natural numbers are also rational, because in the already we knew it. If 2 is a natural number, this can be written as 2 by 1 in the form of p by q, right? Whole numbers are also rational numbers, integers are also rational numbers, and so all these are said to be rational numbers and irrational number. Set of rational and irrational said to be the real numbers. So this is about the introduction of real numbers. In the next video we will see more operations about the real numbers. If you have any queries, you can give us a mail at askagamath@gmail.com. Thank you.